Welcome all in Engineering Stuff channel. Today we'll be seeing how you can make your own RC car using DC motor with flight controller from scratch. So first the CAD model, because I have the 3D printer, so I'm directly exporting the STL file of it, and we know that 3D printer takes a lot of time. Like in this case it took 2 hours to print, so making the video a little bit faster so that you can see how it is printing the chassis of the frame. So now just soldering out the motors. So now we'll connect the motor into parallel connection, making that all the left side motor, if they are moving clockwise, then both the motors should be moving clockwise. Similarly the right side also. Once the connection are made, then we will assemble each of the motor into the chassis and we'll fix it via glue gun. So before that we'll be just soldering out the joints so that it becomes a rigid joint. It won't disconnect or break the circuit. Now placing the right side of the motor, and similarly placing the left side of it, and we'll put the cap. We'll apply some glue gun just to avoid any oscillation or any loose joints, so that it becomes firmly fixed to the chassis of the frame of the vehicle. Once everything is fixed, we apply further glue so that it sticks firmly. Now we'll assemble all the electronic component on the chassis. First the motor driver. So here you can see that the connection we made is for the motor 1 and 2. There is a 5-volt voltage regulator provided on the H-bridge motherboard that will be used to power the FS16 receiver module. Now we need to change the signal which we are receiving, because as you can see, the signal which are fed to servo motor, out of 20 millisecond of cycle, it is comprised of 1 millisecond to 2 millisecond. So in 1 millisecond, in that PWM, it just changes its direction to 0 degree, and if it is 2 millisecond, it will rotate it to 180. So in between, whatever you provide from 1 millisecond to 2 millisecond, that will be proportional to the angle the servo motor will cover. But this signal, if you directly fetch to the H bridge, then your motor will be running to 5 to 10%, because 2 millisecond of 20 is close to 10% of the duty cycle. So you can imagine that it will be rotating only in one direction, and that too not to its full speed, rather 10% of the speed. So here we require a circuit which can convert this signal into proper PWM signal with 100% duty cycle. So that circuit is available in your servo motor. So just take any old servo motor if you have in your, so just unscrew it, and on top you have a potentiometer notch anchor. Just press it, it will come out easily. So here you can see the motherboard of it. So basically this takes the input, and there is a potentiometer whose position you can set it, which will help you to adjust the neutral position and the trim setting. So in neutral position, your DC motor won't be rotating in any direction, so that you need to adjust once you integrate in your existing circuit. And the DC motor where it is connected, we will desolder it so that we can take out the 2 signal wire which we will feed into our H-bridge module. So this will comprise of whatever FS16 receiver module is receiving, and it will convert it into proper PWM with proper duty cycle from 0 to 100% in either direction, either clockwise or anti-clockwise. Else it will be just in one direction, and that too maximum 10%, so you won't be getting good. So now we will quickly just desolder it. So right now I'm just desoldering the motor module. Now once this is desoldered, then we will solder our two wires. So I'm taking two jumper wires, female jumper wire, and I'll solder them. Direction you don't have to worry, because in FSI6 controller you can change the direction via setting, so you don't have to worry about here. So in order to control the entire bot, we require two such signal, one to control the entire left side and other to control the entire right side. So once it is placed, as you can see it here, I have these two servo. One servo is like 13-year-old, so that time the potentiometer was quite different, and the other one, the yellow one, is the recent 3-month-old servo. So both does the same work. Both have the similar kind of circuit which just convert the PWM signal, from the PWM RC controller to proper duty cycle. So now we will place the wire. So here's the live wire, the green color, and the common ground is the central one, which we are fixing it, the black color one. So that is the common ground, and beside that, the red which is connected, that is a regulated 5-volt supply which will be feeding to our flight controller receiver module. So just checking all the connections are intact enough, not loose. And yeah, these are the two servo motor motherboard which we have used to control our H bridge with proper PWM signal from the RC. Let me focus it. So here's how we have wired everything. The blue color socket where we have given our voltage, raw voltage source. So currently we are using a 12-volt lithium lipo battery source, and the jumper cable which are attached, these are our signal to the H bridge, and left hand side are connected to the motor as we have seen. So now circuit wise we are good, everything is almost done. So now we will connect the power. So as you can see, the receiver module is now blinking. So this is how we have wired. So the brown and the red color which you see, it is just the power supply which we have taken from the H bridge, and on the channel 2 and 3 we have connected the servo just to receive the signal, and the motherboard of a servo is just converting into proper PWM signal which we require to control the DC motor. So now we will see how we can bind it and how to use the flight controller basic.
Press both. First thing first, we'll go to the setting, press continuously for 2 to 4 seconds. Once the sign is showing, and click on setting, go to system setting. First you come to the screen lock. No, screen lock. By default the setting is 5 seconds. I change to unlock so that anytime I can do the setting, I can go, else it's become very irritating. Now we'll go to the out stick mode. Again I'll go system, I'll go to output mode, and I'll select PWM IBUS, cross check it. If you are driving drone, then you can go to ppm mode. Okay, but because we are driving DC motor, I'm selecting PWM. Okay, and yeah, model 2 right now is selected. You can check what the model 2 is going to the stick mode. So model 2 means 2 will be this stick, okay, and 3 will be this stick. So my connection are made on 2 and 3 only right now, so I have to use the model 2. Okay, setting accordingly you can change it. Okay, like model 1 is 1 and 3, and then 2 and 4, so whichever suits your requirement you can do it. Okay, fine. So model 2 by default setting. Coming back, then going to the function, if you want to reverse, like, let me show you what this means. If I come here, okay, and if I go up, then you can see it is moving right side. But instead of this, I want, if I move it upward, it should come left side. Then for that we need to come to the reverse, go to the channel 2. By default it is normal setting, so we will just click it here. Now if I go to here, then you can see if I move it to this forward, now it is not coming left side, it is going opposite side. Okay, we will go back and we will again change to normal. Okay, so we are fine with all the setting. Now we have to bind it. So we'll go to system, the first is RX bind, we'll click on it, and now the binding has happened. Now if I move it, this one stick forward, this one forward, both back, right turn, yeah. So this way we have set it up, the RX binding.